Hello my dear students, welcome to your physics class. As you know, we had already started chapter 4, energy. Up to so far we have done work and potential energy. Today we will do the types of potential energy. There are two types of potential energy, that is elastic potential energy and gravitational potential energy. In this chapter, we will study about gravitational potential energy. Formula for this is potential energy is equal to mgh, where m is the mass, g is the acceleration due to gravity, and h is the height. Now, what is this gravitational potential energy? Work done in lifting an object against the force of gravity is stored in the form of gravitational. So my dear students, whenever an object is lifted from ground to some height, the work done on that object stores in the form of gravitational potential energy, because the work done is against the gravity of the earth. Suppose the water stored in a dam has gravitational potential energy. Similarly, a rock on a high hill has this gravitational potential energy. Now you consider a mass object whose mass is m is moved from a ground to a height h. The upward force is needed, and this force is equal to the force of gravitation, which is acting on the object vertically downwards. Now gravity is working downward and we take it to a height h, so we work against gravitational force. If g is the acceleration due to gravity, then the force needed would be F is equal to mg. M is equal to mass, and we have to lift that mass to a height, so we have to work against the gravity. So work done is equal to force into distance. This we have already done. So force here is equal to mass into acceleration due to gravity, and the distance covered here is the height of the object h. So work done against the force of gravitation of earth is stored in the object at height h in the form of its gravitational potential energy. So potential energy here will be equal to mgh. M is the mass of the object, g is the acceleration due to gravity, and h is the height of the object. The SI unit of potential energy is joule. That is same for energy. Now we will discuss the factors on which gravitational potential energy depends. As we know, the formula for it is potential energy is equal to mgh. So factors on which gravitational potential energy of an object depends are: number one, mass of the object. Now, more the mass, greater the potential energy. If you lift a small stone to some height and fall it down, it will hurt someone, right? But if you take a bigger stone, it will hurt more if you take it to the same height. So more mass, more potential energy. Then second factor is height of the object above the ground. More the height, greater is its potential energy. Now you take a stone and go to the first floor, throw it. You if the ground is wet, you can see the impression. Now take that stone, go to the second floor, throw it, you can see a deeper impression, because more the height, greater will be the potential energy. Now my dear students, there are some numerical problems related to gravitational potential energy. In first, a box of 10 kg is lifted to a height of 50 meter. So mass is given, height is given, and value of g you will always take 10 meter per second square. So formula is Potential energy is, you have to find the force acting on. So first of all, you have to find force. So force formula is F is equal to mg. M is given, G is given. So it comes to be 10 by 10, 100 newtons. And gravitational potential energy formula is mgh. M mass is given 10, G is given 10, and height is given 50. So it comes to 5000 joules. Now my dear students, there are two more numericals related to the same topic on page number 64. Numerical number 3. A water tank of capacity 200 kg is placed, this is the mass, at a height 20 meter. Height is given. What is the potential energy? You have to find the potential energy of the water stored in the tank. G is given. It is same, mgh, same, using same formula. Fourth numerical, Pooja takes a suitcase of mass 10 kg from a height 4 meter to 8 meter. She was standing on at a height of 4 meter, then she went to 8 meters. So the height here is 4 meter, 8 minus 4. So you find potential energy. So my dear students, homework time. So please read pages 58 and do exercise questions 27, 28, 29. Thank you and have a nice day.